OLO, Chapter 6, Rational Expressions, more review for our test today. This concept is from 6.4. It's dividing polynomials, and I'm going to use synthetic division, but what we're actually going to talk about in this video is the remainder theorem. So first of all, let's do another practice on this synthetic division. Remember that I have to write this polynomial in descending order, and we are missing an x term. So the way that I'm going to write this out is I'm going to say there's a 2 and -4 coefficient. So positive 2 coefficient here on the cubed. On the squared is a -4. I'm going to have a 0 on my x and a +5. I'm going to divide by, since this is in the form of x minus c, then the actual value of c is literally just 2. Or in other words, you can think of this as the opposite of. So I'm going to, steps here again, bring down this 2. Then I'm going to multiply these together. 2 times 2 is a 4. Add these two together, I get 0. 2 times 0 is 0. So that's going to be a 0 as well. And then I'm going to do 2 times 0 is another 0, and this is going to give me a +5. So remember that we take this coefficient right here and bring it down. So I would get x squared here, x here, a 0 for my constant, and that this right here is again my remainder. So what the remainder theorem says is that if this were a function, a polynomial function, so if it was a p sub x or a p of x, then if I took this value of c right here too, and I put it in and substitute it, so if I wanted to do the p of 2 into this polynomial, so I substitute 2, this means everywhere you see x, put a 2 instead. So I substitute 2 into this polynomial right here and find the value of this polynomial. Well, I'm going to use the order of operations, so 2 cubed is 8, 8 times 2 is 16, 2 squared is 4, and 4 times 4 is a -16 plus a 5. These sum to 0, so the p of 2 is this +5. What you can see here is that the remainder is also the same value if you substitute what you're dividing by into this polynomial for the value of x. It will give you the remainder. So this is what the remainder theorem says. If you're asked to evaluate a polynomial using the remainder theorem, given a specific value, all that means is that if you were given the value of 2, then that means you would have the polynomial, you would be dividing this polynomial by x minus 2. If I wanted to evaluate this polynomial for the value, so if I said, well, what is the p of, let's say, -3? This would mean if I divided this polynomial right here by x plus 3, what would the remainder be? Because this is what I'm plugging in here, okay, in the form of this x minus c. So you can plug in any value you want into this polynomial, and the remainder theorem basically says whatever this value is, what you get out when you plug in this value will be the remainder of the polynomial when you divide it.